Fatty fish such as salmon, sardines, and mackerel are among the most powerful foods for brain health because they provide nutrients that are not only beneficial but structurally essential to the brain itself. The most important of these nutrients are omega-3 fatty acids, particularly DHA, docosahexaenoic acid, and EPA, eicosapentaenoic acid. DHA is a major structural component of brain cell membranes, especially in the cerebral cortex, the area responsible for memory, language, attention, and conscious thought. A significant portion of the brain's dry weight is made up of DHA, highlighting how deeply this fat is embedded in normal brain architecture. When dietary DHA intake is sufficient, neuronal membranes remain flexible and fluid, allowing brain cells to communicate efficiently through synapses. This membrane flexibility directly influences learning speed, memory formation, and information processing. In contrast, low DHA levels are associated with impaired signaling, slower cognition, and increased vulnerability to neurodegenerative processes. EPA, while present in smaller amounts in the brain than DHA, plays a critical regulatory role by reducing neuroinflammation. Chronic, low-grade inflammation in the brain is increasingly recognized as a central contributor to cognitive decline, depression, and age-related neurological disorders. EPA helps modulate inflammatory pathways by influencing eicosanoid production and reducing pro-inflammatory cytokines. By calming inflammatory activity, omega-3s help protect neurons from damage and support a healthier brain environment over time. This anti-inflammatory effect is one reason regular consumption of fatty fish has been linked to a lower risk of Alzheimer's disease and other forms of dementia in population studies. Fatty fish also support mood regulation and emotional health, which are inseparable from cognitive performance. Omega-3 fatty acids influence the function of neurotransmitters such as serotonin and dopamine, which regulate mood, motivation, and emotional balance. Adequate omega-3 intake has been associated with reduced symptoms of depression and anxiety, as well as improved stress resilience. A more stable emotional state allows the brain to allocate more resources to focus, problem-solving, and memory rather than chronic stress responses. This connection between omega-3s and mental health further strengthens the role of fatty fish as a foundational brain food. Vitamin D, another key nutrient found in fatty fish, adds an additional layer of neurological protection. Vitamin D receptors are widely distributed throughout the brain, including regions involved in memory and executive function. Vitamin D plays a role in neuroprotection by supporting antioxidant defenses, regulating calcium balance in neurons, and influencing the expression of genes involved in brain development and repair. Low vitamin D levels have been associated with cognitive impairment and increased risk of dementia, particularly in older adults. Fatty fish provide one of the most reliable natural dietary sources of vitamin D, supporting both brain health and overall neurological stability. High-quality protein in fatty fish further contributes to brain function by supplying essential amino acids required for neurotransmitter synthesis. These amino acids are used to produce chemicals that govern alertness, focus, motivation, and emotional regulation. Protein also supports muscle mass and metabolic health, which indirectly benefits the brain by improving blood flow, insulin sensitivity, and oxygen delivery to neural tissue. Unlike heavily processed protein sources, fish protein is highly digestible and comes packaged with brain-protective fats, making it especially efficient for neurological support. Long-term studies consistently show that people who consume fatty fish 2 to 3 times per week tend to experience slower rates of cognitive decline and better memory performance as they age. Brain imaging studies have even found greater gray matter volume in individuals with higher omega-3 intake, suggesting a physical preservation of brain tissue over time. Importantly, these benefits appear strongest when omega-3s come from whole fish rather than supplements alone, likely due to the synergistic interaction of fats, protein, vitamin D, and trace minerals such as selenium. From a practical perspective, fatty fish represent a rare example of a food that supports brain structure, function, mood, and long-term protection simultaneously. By strengthening neuronal membranes, reducing inflammation, supporting neurotransmitter balance, and protecting against age-related degeneration, salmon, sardines, and mackerel function as true brain-preserving foods. When included regularly as part of a balanced diet, fatty fish do not merely enhance short-term mental performance, but contribute to lifelong cognitive resilience, making them one of the most scientifically supported dietary choices for sustaining brain health across the lifespan.